that I don't have recorded. That way, should you want to go back and review it, you're able to do that. Or for the benefit of those who are not here, they can watch it at their leisure. So we're going to pick up today in Module 1 and hopefully finish our discussion of the vocabulary. Remember, the first few lessons I told you were going to kind of be a little boring because we have to learn how to communicate with one another using the appropriate terminology. And we've talked about over and over how that statistics has its own unique vocabulary. So far, we've talked about variable, population, parameter, sample, and statistic. We looked at the different types of data, which can be either qualitative, quantitative discrete, or quantitative continuous. And then at the level of measurement, which were nominal, ordinal, interval, and ratio. Today, we're going to focus on really two last things. The first of which is statistical research vocabulary. So the vocabulary surrounding the setup of the actual research study. And then also sampling techniques. Okay, sampling techniques. So let's begin with statistical research vocabulary. The objectives, what we hope for you to learn in this lesson is to be able to distinguish between an observational study and an experimental study. To identify the independent and the dependent variable of a statistical study. Explain the difference between a treatment group and a control group. And then differentiate between a blind and a double-blind study. Now, guys, we could get really technical and get really bogged down with some of this terminology surrounding a statistical research study, or really any kind of research study. I'm going to hit the high points. Remember, this is like a survey course, so we're kind of skimming the surface. Okay, we're going to keep it reasonably simple and not get bogged down. Okay, statistical research, scientific research, even market research if you're in business, the intent or the purpose of that research is ultimately to answer a question. It could be a question like, does aspirin reduce the risk of heart attacks? Is one brand of fertilizer more effective at growing roses than another? Is fatigue as dangerous to a driver as the influence of alcohol? It could be something as simple as, what is the average age of a student enrolled at Georgia Highlands College in fall semester 2022? Okay, so typically any kind of research, whether it is scientific, it could be medical research, it could be general scientific research, we're trying to answer a question. And typically that question involves the investigation or looking at the relationship between at least two variables. The relationship between aspirin and the risk of a heart attack. The relationship between fertilizer and the growth of roses. The relationship between fatigue and the influence of alcohol on a driver, and which one is more dangerous, or are they as dangerous? Looking at the age of a student at Georgia Highlands College, and we might want to compare that to, say, Kennesaw or to fall semester 2021. Is there a difference between year to year? It's important from the beginning, regardless of what kind of study you're doing, whether it's scientific, medical, market research, statistical research, that your study is set up correctly or properly from the beginning, Otherwise, your results are probably going to be useless and inaccurate. Okay, so it's important from the beginning that you set it up properly. And so we're going to talk about some of the things that you have to consider when you're setting up scientific or statistical research. There are two different types of studies, two broad categories, if you will, of that we can talk about. Okay, so we're going to talk about what those two are. The first one is called an observational research study, or sometimes we'll just call it an observational study or an observation. Observational study to me is like people watching. Okay. Do you like to maybe go to the park and sit on a bench and just watch people? Or if you're at a ball game and you get distracted and you start watching other people? Or sitting at the mall on a bench and just watching people? An observational study is like people watching. As the researcher, you are simply observing the behavior of what is taking place, what is currently happening at that particular time, at that particular location. Or you could be using past records. Like if I wanted to determine the number of patients that were admitted to the hospital here in Cartersville during 2021 and what they were admitted for. Okay, I could go back and look at the records. So again, I'm just merely interacting or going through records. I'm observing the behavior. I am not attempting in any way to change that behavior, especially if I'm looking at those past records. I can't change whether they were admitted to the hospital or not. I can't change if what they were admitted for. So in an observational study, you are simply observing. You are not interacting with the subjects. Okay, there's little or no interaction with the subjects. And you are not attempting to change anything. The example of the age of a student, if I want to know the average age of a student at Georgia Highlands College in fall 2022, I could look up in the computer records the age of all the students. I wouldn't have to actually interact with you to find that information. And I can't change how old you are. Your age is your age. I can't change that. So I'm not interacting or trying to manipulate or change the behavior of the subjects. I'm just watching. The challenge with an observational study is that it does tend to take place in those kind of natural settings, like at a park, perhaps in a classroom, at the ball game, at a concert. It tends to take place in natural settings, but that also requires the researcher to go to those settings. Sometimes to go to those settings, it may cost money because it might cost money to get into the ball game or to get into the concert. It may not cost you money to go inside the mall unless you decide to go shopping. Probably sitting at a park on a park bench, probably not going to cost you anything, but it does cost you a lot of time because you can't just observe the behavior for 5 minutes. You've got to observe the behavior over a long period of time. Perhaps at different times of the day. You may go one day in the morning, you may go on another day in the afternoon, and you may go on a third day in the evening, so that you can make some comparisons between what takes place morning, middle of the day, and in the afternoon. Okay, so it varies, but it can be expensive and time consuming because you have to go to those locations and you have to spend a lot of time observing. Most times, not always, but most of the time that you are observing, you are collecting qualitative data. Okay, you're recording maybe whether or not people were conversing with one another. Did they appear to be having a good time? Did they appear to be bored? What was their gender? Were they male? Were they female? If you're at a restaurant, you might record what they had to eat. So you get a lot of qualitative data. When you're not going to get some quantitative, because we can talk about, how long were they there at the restaurant? How long was it in between the time that the waiter or waitress came to the table each time? We can get some qualitative data, but more times than not, with an observational study, you're going to get qualitative data. Which is not necessarily a bad thing, but remember, we talked about how we're limited on the analysis that we can do with qualitative data because it's words. The observational study used a lot in the social sciences, criminal justice. I kind of think about some of those TV shows like Criminal Minds, Behavioral Analysis Unit, where they're observing the behavior of criminals. Okay, and they have to do that over a long period of time. They may do a personal interview with a particular criminal that's in jail to kind of get some background information. So again, it's used a lot in social sciences. It's also used a lot in marketing, thinking about the behavior of the consumer. What's the most favorite toothpaste, or what's the favorite color of the new Nike shoe that's being purchased. That kind of thing. Probably the most common observational study that you probably have even participated in, I know you have because we did it Monday, is a survey. A survey, whether it's paper and pencil, on the computer, a mail-in, okay, is an observational study. I had you complete a survey Monday, and I asked you a series of questions. I really didn't interact with you while you were answering those questions. Okay. You answered them on your own. I didn't try to change your behavior. I can't change the number of credit hours you're taking. I can't change the number of hours you work per week. I can't change the number of siblings you have. Okay, so that's an observational study. Again, it could be by telephone. You get a lot of that during this time of the year, especially with the elections going on. Again, the idea of a personal interview, and then especially in business, a lot of times they'll use case studies. They'll think about the different scenarios that can happen, okay, based on perhaps some observations that they've seen previously or that they are seeing in the present. And so they use case studies. Those are some examples of observational studies. Again, the easiest way to remember it and to think about it is that observational research study is people watching. People watching. The second type of study is called an experimental research study or an experiment. Okay. With an experiment, the researcher is manipulating or changing something or trying to determine how that change is affecting the other variables. Think about the example of the roses. We might have 4 different roses, and one of them we put no fertilizer. Then we have fertilizer A, fertilizer B, and fertilizer C. And I want to determine which one of those fertilizers is the best or works better in terms of the growth of the roses. Okay, that's an experiment because I am changing or manipulating what each rose bush gets. For this one, I usually just think about science, typically in a biology class or a chemistry class or physics, you perform experiments as part of the lab. And that's what I tend to think about with an experiment study. We're going to mix these two chemicals together and see what happens. Not blow up in your face. Okay, but that's the idea of an experiment. We are manipulating or changing things to kind of see what happens. Kind of like a test. You usually do have to interact with the subjects. We're making modifications or changes on the subjects. I'm doing something different to each rose bush. I'm doing something different to the chemicals. A lot of times, an experiment occurs in a lab setting or some sort of controlled setting, maybe in a classroom, in a hospital, again, in a lab. So they tend to occur in unnatural settings. We can begin to think about a cause and effect. Because I used fertilizer A, the rose bush grew more than the rose bush that had fertilizer B. We can begin to say, because of fertilizer A, this happened. Can't do that with an observation because we're not really making any changes. You'll see experiments obviously used in the sciences, chemistry, biology, physics, medicine. You can also see it in psychology and sociology. Perhaps, again, they're trying to change someone's behavior through medication, through like group therapy, those kind of things. So it's used a lot in the science-related fields. Probably, again, the most common for me that I think about when I think about an experiment is like a clinical trial for a new medication or a new treatment. And they're trying to decide, does the treatment work? Does it not work? What side effects maybe are occurring with that particular medication or not occurring with that specific medication? And then, of course, any kind of lab experiment is obviously an experiment. Experiments, the experimental research studies, require a little bit more setup than an observational study. I mean, an observational study can be as simple as I'm going to this restaurant and I'm just going to observe people. That was one of my first assignments when I was in my graduate school work. One of the first things, I had a class called educational research, and we were asked to go to a restaurant and just observe what people watch and see what happened. Now, we only did it for 30 minutes. I remember right, not been an hour. Can't remember now. It's been so many years ago. But again, it was that simple. You just pick a place and you go and watch. But an experiment takes a little bit more effort in the setup. And so let's talk about some of the setup that's required, specifically if you're going to do an experimental research study. Before we do that, let's look at some examples though. Sorry, got ahead of myself. Okay, here's a scenario. Subjects were randomly assigned to two groups. One group was given an herb, and the other group was given a placebo, something fake. After a year, the number of respiratory tract infections each group had were compared. Is that observational or experimental? Why? They modified or manipulated it because some of the people got the herb, some people got the placebo or a fake. That is experimental. We manipulated something. GHC's president wants to know the average age of students enrolling in fall 2020. He uses the students' records in SCORE to determine the age of each student. That is purely observational. He used the records from SCORE to get the information. He didn't interact with the students, and he couldn't change their age if he wanted to. That's observation. A researcher stood at the entrance of GHC to see if the color of the automobile a person drives is related to running red lights. Again, that's observational. I'm not trying to change the color of the car. Couldn't do that if I wanted to. I'm just observing whether the white car ran the red light or a blue car ran the red light or whatever. Okay, I'm not trying to change it, and I'm really not trying to change whether they run a red light or not. One more. A dentist wants to research the effects of a new dental material used to make fillings. That's experimental because he's going to probably try or has tried the old material, and now he's going to try this new material, and then he can compare. He's manipulating something or changing something. Okay, that is experimental. Questions? All right, now let's talk about the parts or the pieces that you need to think about when you're setting up an actual experimental research study. Yes, ma'am. Yes, ma'am.
So if the question
that would be observational because he's looking at the other studies. He's kind of using the research that's already been done. And so that's more observational because he's just reading the reports. He's not actually doing it himself. All right, when you are conducting an experiment, again, we're usually looking for a relationship between at least two variables. And so those two variables have special roles to play. One of them is the independent variable, and the other is the dependent, which we'll talk about in just a minute. The independent variable is sometimes called the explanatory variable. Called the explanatory variable. It's the variable or the thing that is being manipulated or changed by the researcher. Okay, the independent or the explanatory variable is the thing that is being changed. Think about the roses. Okay, I have one that's getting no fertilizer, one that's getting fertilizer A, a third that's getting fertilizer B, and a fourth that's getting fertilizer C. My independent variable is the fertilizer. I'm changing the brand of the fertilizer from rosebush to rosebush. That is the thing that is being manipulated. In the example we just looked at, they got an herb or they got a placebo. So my independent variable was whether or not they got the herb or the placebo. Which treatment or which medication did they get? It's called the explanatory variable because if you think about it, it's the variable that explains what's happening in the experiment. The fertilizer or the brand of fertilizer explains the growth of the rosebush. The herb explains why they had fewer respiratory tract infections. Just like we do in algebra, typically the independent variable is called X or labeled with the letter X. Opposite that independent variable, we have the dependent variable. Dependent is sometimes called the response variable. Response variable. And basically, it's the response or the result of that particular treatment or manipulation. What happened when we used fertilizer A or fertilizer B or fertilizer C or no fertilizer at all? The result or the response is the dependent variable. The growth of the roses depended on which fertilizer I used. So the growth is the dependent, and it's the one that you're kind of asking a question about. Which of the fertilizers are better? Or which one makes roses grow better, grow more? And again, it's typically represented by the letter Y. So usually within an experiment, we talk about the X and the Y. Now you can have more than one independent variable, and we can have more than one result too. That gets into a lot more complicated experiment than we want to talk about in this course. Okay, but typically in an experiment, we're going to compare or look at the relationship between two things. You have your independent variable, which is the thing that you are manipulating or changing. And you have your dependent variable, which is ultimately your final result. Additionally, once you've decided what is your independent variable, what is your dependent variable, we got to make sure that we set up the experiment correctly. And when you're reading research that's been done, you may run across some of these words. I want to make sure you kind of know what they are. I've been using the word subjects or items. Kind of the official term is an experimental unit. Okay. It is the single object or individual that we're measuring. My individual rose bushes. Okay. Those are my experimental units. Now, ideally, you want those experimental units to be, in a sense, uniform or have similar characteristics. I would want to try to buy the same brand of rose, hopefully that are all similar heights to make it easy for comparison purposes. Okay, if the study is, related to students at GHC, the age question we had a while ago, I only want to look at students at Georgia Highlands College. I don't want to go to Kennesaw and look at ages of students down there, or go to Georgia State and look at students there. Okay, so your experimental units, or sometimes called your subjects, it doesn't have to be people. It can be reports. It can be things like rose bushes. And then we have, and again, we've kind of talked about this, we have treatments. The treatments are the different values of your independent or explanatory variable. Okay. The treatment is the different values. So if I'm thinking about my roses, I have fertilizer A, fertilizer B, fertilizer C, and no fertilizer at all. So in this case, kind of depends on how you look at it. You either have 3 treatments, because you got fertilizer A, B, and C, and then I got one where I'm not doing anything. Researchers disagree here. Okay, depends on the researcher, even depends on the author of the textbook. The one that you're not manipulating is what we call the control. And we'll talk a little bit more about that in a minute. That's your control. And some researchers view that as a treatment because it's getting no treatment, and some don't. It just depends on who you're dealing with. But the treatment is those manipulations. And typically you're going to have at least two. And I think about it in terms of at least two because you got to have a control. And then you could have a minimum of one treatment. Think about the filling question a while ago. You would have the old treatment, that would be your control, and the new treatment. So there's my two. I just mentioned to you that typically when you're performing an experiment, you want to have that control group. You want to have a group that doesn't get the treatment. I want to have a rose bush that gets no fertilizer at all. Because it might be it grows better without any fertilizer. Sometimes, though, in order to kind of keep the ground level when you're doing an experiment, you may want to use a placebo, which is a neutral or a false treatment. Because like if you're testing a new medication and you have a group and they kind of know they're not taking the medication, and you have the group and they know they're taking the medication, that doesn't really work. So we oftentimes will give the group that's not really getting the medication, we'll give them some placebo, some little sugar pill you'll hear people talk about or something like that, so that they think they're taking something, but it's not necessarily the actual medication. So you have to have a control because that control group creates the baseline for comparison purposes. My no fertilizer rose is going to give me a baseline for comparing fertilizer A, B, C. Okay. And I think that was what the next line said. Yeah, the comparison purposes. The treatment groups then are the ones that actually get the treatment. Fertilizer A, fertilizer B, fertilizer C. The one who has the old filling versus the new filling. And you can have multiple treatment groups. I would have 3 treatment groups because I have fertilizer A, fertilizer B, fertilizer C. So that's 3 groups. But now notice each group only gets 1 treatment. I'm not mixing fertilizer A with fertilizer B or fertilizer B with fertilizer C. It gets 1 group, gets 1 treatment. Otherwise, you can't decipher which one is the, for comparison purposes, you can't decipher that. You can have multiple groups, and a lot of times in an experiment, just because of the cost associated with it, they'll use we can do 3 at a time instead of just doing 1 at a time. I could do 10 at a time instead of doing 1 at a time. Again, that's going to save me a little bit of time and probably a little bit of money over the long haul. Up your control group and your treatment group, you want to be sure that you use a random assignment, that there's not, a pattern, a rhyme, or a reason why, one person is in the control group and one person is in the treatment group. It could be as simple as if I went around the room, probably in elementary school, you had teachers do this. She'd say 1, 2, 1, 2, 1, 2, 1, 2. Okay, you're group 1, you're group 2. That's random enough. Setting up your control group and your treatment group, you want them to have what we call, or be what we call homogeneous, or have homogeneity, meaning the characteristics for each group are the same. Then I bought all 4 same brand of roses, same type of roses, same color. Okay, because that can have something to do with it. So I want to try to control as much as possible. So I want to make sure that I have similar groups. And I want the characteristics of my groups to be similar, ideally, for comparison purposes. Sometimes it's important that the participants know which group they're in, and sometimes it's important that they don't. Because if you know you're in the group that's getting that new medicine, you might behave differently than you would if you knew that you weren't getting that medicine. So oftentimes in a research study, we use a process called blinding. Okay, blind means you can't see. Okay, so the idea of blinding is that you, as a participant or as an experimental unit, as a subject, do not know which group you're in. That's why, especially if it's like a medication, okay, one group gets the medication that's placebo, one group gets the medication that's that they're testing. But both groups get some sort of medication, and then they don't know which group they're in. Again, that helps to eliminate some of the bias that could occur. There is apparently, sometimes they say, now quite honestly, I've never seen it done in any research that I've done or any research that I've read, but some people will argue that sometimes it may be that as the researcher, I wouldn't know which group is which. You might know which group you're in, but I don't know. And they also consider that blinding. But I'm like I say, I've never seen that done. I've never heard of it being done. The researcher may know, usually knows, unless we're using a double-blind model. In a double-blind model, neither you, as the participant, nor I, as the researcher, know which group is which. A third party, maybe the research assistant, the secretary, some outside source sets the groups up. And I don't know which group is which, and you don't know which group you're in. It's called double blind. And again, that helps to prevent, my behavior affecting your behavior in response to a question. Because if I know you're in a certain group, I may ask a question differently. I may ask it a certain way to evoke a certain response, and that could cause issues in the research. Okay, so blinding is where typically the subjects do not know which group they're in. Double blind is neither the subjects nor the participant or nor the researcher knows which group is which. Now again, we can get real fancy. We can talk about multi-stage experiments and all that kinds of things. We're not getting that deep. We're just kind of keeping it as basic as we can. Okay, so let's look at a couple of examples here. One last thing I forgot about. It's kind of lurking in the background. Sometimes when you're doing research, you're trying to look at maybe, the effect of that fertilizer on the rose bushes, or whether an aspirin can help prevent heart attacks. Okay. And you try to control as much of the research as you can. I try to control the amount of water that each rose bush gets, the amount of sunlight, how long it gets sunlight. I try to control all those things. But sometimes maybe there's something that we don't think about, or there's something that we think about but we can't control it. That's called a lurking variable. It's kind of in the background, it's going on, and it could affect your results. Again, we try to control it if we can, but if we can't, we simply document that the results will be affected by the fact that rose bush A got more sunlight than rose bush B. Okay. So sometimes it's like something that, again, we may not even be aware of it from the beginning of our experiment. That's kind of why it's lurking, because it's hiding. Just be aware that those things could possibly be there and can affect it. Now the examples. I'm getting there. Okay, here's your scenario. Researchers want to investigate whether taking aspirin reduces the risk of a heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are randomly divided into two groups. One group will take aspirin and the other group will take a placebo. Each man takes one pill each day for 3 years, but he doesn't know whether he's taking an aspirin or a placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. Okay, given that scenario, what is your explanatory or independent variable? The aspirin. Basically, the medication that's being taken. Are you taking the aspirin or are you taking a placebo? That's what's changing from group to group. That's the thing that's being manipulated. What is the response variable? Whether or not they had a heart attack, because it says they're going to count at the end whether or not that a man had a heart attack or not. It's going to be a yes or no question. Did you have a heart attack? Did you not? How many treatments do we have? We have a control group and one treatment. Again, some researchers will argue that that's 2 treatments. Okay, 2 treatments because one group got the aspirin, one group got nothing or placebo. The one that got nothing is technically the control group. Does this study involve blinding? Yes. And it's reasonably obvious because it says he does not know whether he's taking an aspirin or the placebo. Okay, second scenario. The Smell and Taste Treatment and Research Foundation conducted a study to investigate whether smell can affect learning. Subjects completed mazes multiple times while wearing masks. They completed the paper and pencil mazes 3 times wearing floral scented masks and 3 times with unscented mask. Participants were assigned to at random wear the floral mask during the first 3 attempts or during the last 3 attempts. For each trial, researchers recorded the time it took to complete the maze and the subject's impression of the mask scent, whether that scent was positive, negative, or neutral. Did they like it, not like it, or did they just not care? Okay, what's the independent variable here, or the explanatory variable? What's changing? The mask, whether they're scented or unscented, or whether the smell affected it. What's the response? Okay, time to complete the maze and how they felt. There are actually 2 response variables here. You get one that's quantitative because you get the time that it takes them to complete the maze with a particular mask on. And then you get their impression of the mask, which is qualitative. Right? So you get, there's 2 responses here, and that's okay. Again, they'll often say the more data you can collect, the better. What were the treatments? The scented and the unscented mask. Again, in some ways, the scented, I suppose, would be your control. I think you could almost add a 3rd group here and have them do it without the mask. You know, do people learn better without a mask at all? Or if they have to wear a mask, is unscented better or scented better? So, you know, again, you could have that argument. But in this case, they're probably using unscented as the control and the scented. But notice they're also only doing floral scented. And it said it had them do it 3 times. So I wonder if they changed the floral scent. It doesn't tell us. You know, maybe one time they use a rose, next time they use I don't know, a daylily or, did they change it or was it the same? They don't tell us. We don't know. Does this one involve blinding? Would that scenario have blinding? I don't really think it involved blinding because if I put a mask on, I'm gonna know whether it's seen it or not. And both groups did both things. It's just that some of them wore the scented first and some of them wore the scented second. And then, but that also lets you know, does that make a difference? If you change from scented to interesting study to do, especially in recent years. I prefer none at all. Thank you very much. All right, questions on statistics, research vocabulary before I switch gears. Okay, I'm going to switch gears to statistical sampling. And I think I talked about it, or at least commented early on from the beginning of any kind of research study, even whether it's observational or experimental, it's important that you make sure that you select your sample correctly. Okay, the idea of sampling, just in case to remind you, remember we start out with a big picture focus. What do we call that big picture focus? The population. And we talked about how difficult it would be to get information from every single person in the population. So more times than not, when we conduct research, we use a smaller group, a subset of the population. What do we call that subset of the population? It's called your sample. And so it's important that we select that sample in such a way that it doesn't affect our outcome. Okay, so I'm skipping over some of that. But when you select a sample, it's important because you want to make sure that you represent the population. Go back to the example a while ago with the aspirin. Okay, it said they selected 400 men between the ages of 50 and 84. That actually limits to whom we can apply the results of that study, because the results of that study can only be applied to men who are 50 to 84. We would not apply those results to women, nor would we apply them to probably most of the men in this room that are between 18 and 49. Probably all of them. I don't think any of you are 50 or older, unless I'm way off base. Okay, so it's important that you are careful about the way you go about selecting that sample from the population. Your sample should ultimately be two things, R and R, I call it, representative and random. Okay, every sample should be R and R, representative and random. Representative means that the sample has the same characteristics as the population. Okay, so if we're talking about students at Georgia Highlands College in fall semester 2022, okay, I'm not going to go down to Kennesaw or Georgia State or Berry or Shorter and get information from those college students, because they are not students at Georgia Highlands College. Nor would I go back, 10 or 20 years and ask students, okay, because I specified fall 2022. You want your sample to be representative. Again, if you know that your population is 60% male and 40% female, then you want to try to ensure that your sample is 60% male and 40% female. Always think about it like you want it to be the jury of your peers. And so you want your sample to be representative. The other thing is that you want that sample to be random, meaning your subjects were selected by chance. There's no rhyme or reason, no pattern to why they were selected to participate. They're selected purely by chance so that everybody within the population, the whole entire population, had the opportunity to participate. Okay, so you want to always ensure whenever you're doing either an observational study and definitely when you're doing that experimental study that your sample is representative and random. We're going to look at some techniques in this course that will help us do that. Some ways we can choose our sample so that we ensure we have a representative and a random sample. There are 5 that we're going to look at: random, convenience, systematic, stratified, and cluster. Now, for our purposes in this course, we're going to look at those 5 different sampling techniques as standalone techniques. That we're only going to use the random method, or we're only going to use the systematic method, or we're only going to use convenience. In reality, in the real world, researchers often do what they call multi-stage sampling, and they use different techniques at different points of the research, again, to ensure that we have that representativeness and the randomness. But we're not going to look at them in that kind of multi-layer deal. One technique per scenario. Again, that's for the purposes of this course. So let's talk about these 5 and see if I can get through them. We got about 14 minutes. Random is the first one, or it's sometimes called a simple random sample. Simple random sample is where each person, each item in the population has an equal chance of being selected. Every person, every item in the population has an equal chance of being selected. The easiest example for you to relate to is the idea of drawing names from a hat. Okay, if I took and wrote all of your names on a piece of paper, tore them apart, folded them up, put them in a hat, mixed them up, and started drawing names out, that's just purely random. Now, if you've got tens of thousands of names or tens of thousands of participants, drawing names out of a hat really is not ideal. So we can use something electronic called a random number generator. And I'm going to show you what a random number generator is. I can Google it. You can find them all over the internet. So if I go and Google random number generator, okay, it pops up. And even just this first example here, it allows me to put in what I want the minimum value to be. And what do I want the maximum value to be? So if I start at 9001000000, I can generate Georgia Highlands ID numbers. Okay, so if I click generate, I get 9001-87031. So the student who has that particular ID number would be selected to participate. I can tell it to generate another one. Okay, you can tell it, this one's doing individual numbers. You can have it generate 20 numbers, 30 numbers at one time. Okay, but that's what we mean by a random number generator. Sort of like another way, like rolling a dice. You had things numbered 1 through 6, you could roll a die. Okay, but everything has the same chance of being selected. That's random. Okay, let me go back over here to the PowerPoint. The second one is called systematic. Systematic. With systematic, we select a random starting point, and then we select every nth subject in the population. And you may think, well, Ms. Ralston, that's kind of got a pattern to it. Well, it does, but what makes it random or what makes it permissible is the fact that we choose a random starting point. Maybe we use that random number generator to generate my starting point. Or maybe I just close my eyes and drop my finger on the page. Maybe I just like a particular location or particular number, and that's where I'm going to start. This particular method is very easy to use. It's also a great one to use if you're looking at reports, because if you've got a list of reports, you can go 1, 2, 3, pull, 1, 2, 3, pull, 1, 2, 3, pull, and you can pull reports very easily. So it's a very easy one to use. Again, it's not necessarily, again, a lot of people think, well, it's got a pattern to it. It does, but it's because you pick that random starting point that makes it permissible. I usually tell students, if you're trying to identify this one in a scenario, you want to look for the word, because you're going to select every 5th, every 10th, every 20th. I suppose it could be because you could pick the 3rd, every 3rd. Okay, but usually you're going to look for that word in the description. Third one is convenience. The third one is convenience. Convenience, you use results that are readily available, that you have easy access to. For example, I have access to all of your records within the score because you're my student. So even though I asked you some questions on the survey Monday, I could look up other things like your GPA. I can look up your address. I can look up your phone number. I can look up your previous coursework, because I have access to you in the computer system because you are my student. Access to you. Also have access to you here in the classroom because you're supposed to be in here from 12:30 to 1:45 on Mondays and Wednesdays. So I have access to you that way as well. You ever been to the mall? Sure, we haven't right been on. Have you ever had somebody come up to you with a clipboard and want to ask you questions? Yes. Some people are shaking their heads no. The class this morning said no. I thought that was unusual. Maybe they don't do that much anymore. I don't know. But it used to be they would have, especially for like marketing purposes, they may be asking you what stores you're visiting. What are you purchasing that day? It's like a survey company. They come up to you and they try to ask you questions. And they can do that because they have a captive audience. You're at the mall. They have access to you. They can go to that one location and get information from a lot of people without having to go all over the place. That's convenient. The example here is they're yelling out the window. The thing is, you have to be careful if you're using a convenient sample. Even thinking about the mall example, depending on the time of the day that you're there or the day of the week, think about who might be at the mall. I mean, if you go on, say, a Monday morning, you're probably either going to have parents or moms with young children who are not in school yet, perhaps retired people, maybe people that are unemployed looking for a job. So you don't get a full cross section of people. Whereas if you went like on Friday night, you might get teenagers. Or on a weekend, you might get more teenagers. You have to be careful. Think about it as like if you were going to use your family members. And we use the question that's on the cartoon. Okay, family members, family groups tend to have similar opinions. And so you're going to get a lot of opinions on one extreme or the other, and not a nice cross section. You have to be careful using a convenience sample sometimes. Another convenient sample. Hey, you guys, y'all listen to the radio? Sometimes they'll ask a question and you can call in. That's a convenient sample. They have access to you because you're listening to the radio. Of course, then you get to choose whether to participate or not. But they have access to you. All right, the last two of the 5 are probably the best of the 5 options in terms of selecting a sample. They're also the 2 that students tend to confuse and get mixed up. Okay, so I want to try to help you make sense of them. The 4th one is called stratified. The 4th one is called stratified. With stratified, we take our population, we take the big picture, and we divide that population into groups based on some characteristic. It might be several characteristics. The diagram that I have up there takes the population and then divides it by gender, male, female. We could also divide it by age. You can put the 20s, the 30s, the 40s, the 50s. So you can do gender and age or just age, but you're dividing the population into groups by some characteristic that you have selected. A lot of times it's a characteristic you're trying to control. It's a characteristic, one of those lurking variables you're trying to control. Okay, so we divide them into groups and then we select some from each group. Okay, notice the word sum on this slide is red and capitalized, which means it's an important word. The word sum and the word stratified both start with S. So that's how I try to remember it. Stratified is groups, and I select some from each group. Now, here's where you sometimes see that multi-layering deal, because we divide them into groups, and then to select the sum from each group, we may use a random number generator, or we may use systematic. Okay, again, we're not worried about how they choose those sum, but that's where it could happen. Stratified, again, the benefit is it's going to give us that more representative sample. Again, think about if we divide by gender and we know the population is 60% female or 60% male and 40% female. I can select from my group so that I take 60% male and 40% female. You don't have to take the same number from each group. So it gives you that more representative sample. It also lets you to preserve or control some of those characteristics that could be considered lurking variables. The last one is cluster. Okay, cluster sampling, you also divide the population into groups. Now, this diagram here says it's natural grouping. This one you see a lot, maybe think about like dividing the state of Georgia into counties, okay, or into regions. So we're still dividing the population into groups, but instead of selecting some from each group, we select the entire group. We use all of the people in the group. I could send somebody to Gordon County to get information from people living in this county. I could send someone to Cobb County. That could be all the people. You see this particular technique used a lot by the government and by like market or private research organizations. Again, because they can send somebody to a central location out of which they can work, and they do all the people in that area or region. Probably the easiest example to think about, especially right now, is the idea of an exit poll. Typically during an election, especially on election day or election night, they try to predict who's going to win the race before it's actually over. And they use an exit poll. And what they've done is they've sent a reporter or researcher, somebody, to a particular polling location. And they've asked every person that's come out who they voted for. And then they take that information from that local polling place and kind of expand it out and say, you know, Biden's going to win the race in Georgia, or Pence going to win the governor's race. Okay. So the difference is with cluster, you still have the groups, but you're going to use all of the group. Now, I've run out of time, so I haven't gotten to the examples. We did not get to class participation 3. Don't panic. It's fine. Okay. But if you've not done class participation 2, that you didn't finish in class Monday, you need to get it turned in. I'll see you Monday. Thank you, ma'am.